All right, so we're into part two. Part one, we kind of we left off with some more complicated examples, but I'm going to revert to this first example that we touched on. So let me go back here. I'll even erase this. So keeping in mind what you do with the distributive property is I'm going to erase the 6 as well. Let me just eraser tool. Goodbye, goodbye. You take the 3 that's in the front and you distribute it to each term. So 3 times n and 3 times 5. In this video, we're going to show why, in particular, like this result is true. And to do this, we're going to reference multiplication. So multiplication is defined to be repeated addition. And in the context of this video, I'm going to go ahead and say the thing in front, 2, we're going to think of as how many times or how many 3's are being added together. And I realize now that I wrote times there, it should be plus. 2 times 3 is just 3 plus 3. 2 3's added together. Well, in the same way, in the same manner, I'm going to store this to the side here. 3 times n plus 5 is just n plus 5 plus itself, such that 3 of them are added together. N plus 5 once, twice, and 3 times, all added together. That's what this expression means. That's what multiplication here means. 3 of these added together. Now, of course, this notation is a little bit more compact. However, expanding this out actually does a lot for us because, first of all, parentheses tell us to readjust the priority. That now addition is more priority than multiplication, so we do this first. However, when you expand this out so that you only deal with addition, there's no real change in priority anywhere because everything has the same priority. It's all addition. So we don't need parentheses here. And another thing about addition is that we say it's commutative, meaning we can add things together in whatever order we like. In other words, we can kind of combine like terms readjust like terms as in the following manner. So for instance, we could write n plus n plus n plus 5 plus 5 plus 5. And if you don't believe me here, try doing like 2 plus 3 plus 2 plus 3 plus 2 plus 3, and then do 2 plus 2 plus 2 plus 3 plus 3 plus 3, and verifying that these are, in fact, equivalent. But at any rate, we have this expression here now, n plus n plus n, and 5 plus 5 plus 5. Note, that is exactly what we have multiplication to be defined as. 3 times n and 3 times 5. Well, look, that's what we had. This is the distributive property. It's just expanding out, regrouping, and then compressing. And we can essentially skip all of this stuff because it's always going to be the exact same procedure and just summarize by writing this. And then, of course, we can simplify and actually do the multiplication there and get 3n plus 15. And then, boom, that's the distributive property. Right. So what I'll also say is if we were to extend this example, this will be the last thing I do in part 2, to be instead of 3, we do 4. Notice that all that's going to mean is that we add an extra copy of n plus 5 to the end. And so, similarly, we're going to take each part and add an extra n and an extra 5. Which means instead of 3 copies, we're now going to have 4 copies of each. And I lied because I actually want to do one more thing before I go to the monster in part 3, which is the following. I'm going to do it with a simple example. We're going to use 2 on the outside, but we're going to do x plus y plus 1. This expression has two different variables in it, has the number 1 involved as well, and it involves 3 different terms, as opposed to here, the previous example, where we only had 2 terms. We're going to go ahead and show that this is equal to 2x plus 2y. Wow, that was really bad. 2y plus 2, or 2 times 1. Now to do this, hopefully you can kind of beat me to the punchline. It's x plus y plus 1 plus x plus y plus 1. Just add the thing to itself. There's 2 copies of them, so you have 2 of them added together. And this is, we'll take away the parentheses because they don't matter because it's all addition. And you have x plus y plus 1 plus 1. 2x, 2y. That was a really bad squiggly curly brace. And then 2, or 2 times 1. Add them all together, and hey, we got what we want. And we can extend this to be more than 3 terms, so on and so forth, and that's what we're going to do in the final part, dealing with the monster. And yeah.